In question 9, functions f and g are both defined for x as an element of real number and are given by f of x equals to 4x squared minus 4x plus 9. G of x is 2x squared plus 4x plus 12. In part A, we have to express f of x in the form x minus a whole squared plus b. So for f of x to convert it to x minus a whole squared plus b, this is the full square form. So when we are completing the square, first we add half b to the equation. So this will become x squared minus 4x plus 2 squared. And as we have added 2 squared over here, so we'll subtract 2 squared as well, plus 9. So this will become x squared minus 4x plus 4 becomes x minus 2 whole squared. And minus 4 plus 9 will become a plus 5. So the values of a will be 2 and positive 5 for b. In part B, we have to express g of x in the form 2 into x plus c whole squared plus d. In this case, we will use the comparison method. So g of x was 2x squared plus 4x plus 12. Now we can still use the completing the square form up here, but as we have already done completing the square method in the first part, so we'll use comparison method to convert g of x in this particular form. So now taking 2 common from g of x, this will become x squared plus 2x plus 6. And as we have to convert it to the form x plus c whole squared plus d. So expanding x plus c whole squared, that will become x squared plus 2xc plus c squared plus d. Now comparing, so the coefficient of x is 2c and over here is 2. So we can say that 2c is equals to 2 and c equals to 1. The constant, which is c squared plus d, over here will be equals to plus 6 up here. So this will be equals to plus 6. Now as c is 1, so this will become 1 squared plus d equals to 6 and d will be equals to 5. So we can write a final answer as g of x will be equals to 2 into bracket. So c is equals to 1. So we'll write x plus 1 whole squared and d is 5. So this will be plus 5. In part C, we have to express g of x in the form k f of x plus h. Now f of x was x minus 2 whole squared plus 5. So first let's write f of x was equals to x minus 2 whole squared plus 5. And g of x, we converted it to the form. So g of x was 2 bracket of x plus 1 whole squared plus 5. So if we have to express g of x in the form k f of x plus h, it means we have to multiply the function f with a constant k and add a value of h up here to make it equals to g of x. So in the first step, what we'll do is we can multiply this whole function by 2. So we can write this as 2 into x minus 2 whole squared plus 5. Now the difference between g of x and this function is that there's a plus 1 up here. And as we have to add a value up here, so to make minus 2 to a plus 1, so we'll have to add a 3. So this means we'll have to write this as x plus 3 minus 2 whole squared plus 5. So this will become 2 into x plus 1 whole squared plus 5, which was the expression for g of x. So we can say that in this case, the value of k will be equals to 2. And as we added 3 up here, so we added 3 to h, 3 to x, it means that the value of h will be equals to 3. In part D, we have to describe the two transformations that have been combined to transform the graph of f of x to the graph of g of x. Now we had f of x, which was equals to, so f of x was x minus 2 whole squared plus 5. So we multiplied the function by 2, which means that there was a stretch in the y direction first, as we have multiplied the whole function by 2. So this will be a stretch in the y direction, and the scale factor will be equals to 2. And as we added 3 to h, it means that there was a translation. and the translation vector will be 3 and 0, as the graph was only moved positive 3 units in the x-axis.